Solving quadratic equations with negative leading coefficients. We're going to continue our study of quadratic equations. Remember, quadratic equations are in the form of ax squared plus bx plus c equals 0, where a does not equal 0. That gives us the second power on the x. We are going to solve and check the problem minus x squared minus 6x plus 7 equals 0. And we have several methods to do that. The first one we're going to do is to factor the equation with the negative in place. Now we look at this and we can see that there are no common factors greater than 1, so we're going to go ahead and factor this trinomial into binomials. To get a negative x squared, you need one of the factors of x to be negative and one to be positive. To get a 7, we need factors of 7 and 1. Since we know one of the factors is going to be a negative, we have to subtract to get a 6, and we need a negative 6, so we're going to put the 7 over here across from the negative x, and our 1 has to go here with this x, the middle terms, and it's a positive 7, so both the 1 and the 7 have to be positive. And we're going to check our work now using FOIL. First, negative x times x is x squared. Negative x times 7 is negative 7x. Plus 1x gives us our negative 6x, and 1 times 7 is 7. Now using the zero product property, we know that minus x plus 1 has to equal 0, or x plus 7 has to equal 0. Because these two factors multiply together to give us 0, one of them has to equal 0 or the other. To get the x alone, we don't want a negative x, we're going to go ahead and add x to both sides, and 1 equals x. Or on the other side, we could subtract 7 from both sides, and we have x equals negative 7. We have to check both of those answers in our original equation. We're going to tell what we're checking. The first time through the equation, we're going to check 1. The second time, negative 7. Rewrite the original equation for both checks. There's never any algebra in the check, only arithmetic. Substitute. 1 squared is 1. We want the opposite of that, so it's minus 1. Negative 6 times 1 is negative 6. Negative 1 minus 6 is negative 7. And negative 7 plus 7 is 0. So 1 is a solution to that quadratic equation. Now we're going to check negative 7. The negative 7 has to go in parentheses because we are squaring the negative 7. Negative 7 times negative 7 is 49, and we want the opposite of that, so we're bringing down the outside negative. Negative 6 times negative 7 is positive 42. Negative 49 plus 42 is negative 7, and negative 7 plus 7 is 0. So this equation checks. This solution checks in the equation, and our two solutions are negative 7 and 1, and we have our solution set. Now we have the same equation written down 2 more times. Another way to solve the problem, just make sure this is out of the way, is with additive inverses. I don't want a negative x squared, so I'm going to add x squared to both sides, and I'm going to move everything else over at the same time by additive inverses, doing the same thing to both sides. So I have minus x squared plus x squared is 0, minus 6x plus 6x is 0, and plus 7 minus 7 is 0. So I've essentially moved the 0 to this side of the equation, and now we have x squared plus 6x minus 7, which is easier to factor than a trinomial with a negative leading coefficient. We have to factor x squared into x and x. We have a negative 7 here, so one of the factors of 7 is positive and 1 is negative. Because in this particular trinomial we have a positive 6 left over, then we need a positive 7 and a minus 1. Again, if you check these, look over here, these were the factors that we had. We will end up with a positive 1 and a negative 7 for our answer, so I'm not going to go through the rest of the solution. This is another way to solve the exact same problem. The third method I think is the easiest. We can factor out a negative 1. When we do that from this side, we're left with x squared plus 6x minus 7. And then you factor your binomial into the same factors that you had over here because it's the same trinomial. And in this case, -1 cannot equal 0. That would be silly. But these two, oh, that should be x minus 1. X plus 7 could equal 1, or x minus 1 could equal 0. X plus 7 could equal 0, or x minus 1 could equal 0. And then you would solve it, and you would have the same answers. Another way to solve the same trinomial is to, quadratic equation, is to multiply both sides by -1. Multiply this side by -1, multiply that side by -1, and we get x squared plus 6x minus 7 equals 0. Do the same thing to both sides. You should get the same answer. And again, it's set up the way we had it set up here and here. So we're going to get the same answers. Our solutions to this equation will be -7 and 1. I'm going to give you two other equations to try on your own. Here is the first equation. 9a plus 20 equals -a squared. I want you to shut off the video, try it on your own, and then turn it back on when you're done and check to see if you have a correct solution. So go ahead and turn it off. In the meantime, I'm going to turn the solution over. This is one solution to the equation. So if you follow through, you can check your work. You should have the answers -5 and -4. Problem number 2. I'm going to give you this equation, the quadratic equation, which is -u squared plus u equals -30. Go ahead and shut off the video. Do the work on your own. Shut it off now. When you turn it back on, this is a solution to the quadratic equation. You should have -5 and 6 as your answers. And we're going to go ahead with our study of quadratic equations when you come to class tomorrow, Monday, and we will do some more difficult problems with fractions as answers. But until then, have a great day. Bye.